6.6 solving radical equations. So we always want to wrap up or near the end of the chapter, look at how do we solve using whatever we've been working on. And so that's the case here again today. We do have definitions, or actually just one. And it's called the principle of powers. Principle of powers. There. And it states if A equals B, then A to the n equals B to the n. So essentially, this means if two things are equal, so we have an equation, then we can raise both sides to the same power, and it stays equal with that. So we'll do one side, we'll do the other. Still another case for that here. Okay. All right, so let's just hop right into our examples now. And we're going to solve and see what we have. So let's start here. That's supposed to be a minus 3 equals 4. So we have square root of 2x minus 3 equals 4. All right, so anytime that we have a square root, we need to get rid of it. Before we can do that, we need to verify and make sure that there is just a square root equals something. We don't want anything adding or subtracting outside of the square root. Now, we can have multiplication. We'll talk about that later. But first, we just need to make sure there's no adding or subtracting outside that square root on that same side. In this case, there's not. The square root's by itself. We can see there's nothing following it before it with adding or subtracting for those. Once we've done that, we look at the index. So we see that the index here, because it's a square root, is a 2. And we're going to use 2 as our power. We're going to square both sides. Like so. Now, the good thing for that, the reason why we do that here is the square and the square root cancel each other out, leaving us with 2x minus 3 on this side. On the other side, we get 4 squared, which is 16. And now we've created an equation that doesn't have a square root in it anymore. We just need to solve for x. So we're going to add 3 to the other side. We get 19, divide by 2, so x is 19 over 2. But we do have to check some things. And we can do it a couple of different ways. But we have to make sure that that x value is in the domain. And we can do that by physically finding the domain. This problem, which is not hard to do, we could do that. But later on, we're going to see we're going to have multiple square roots, and finding that domain is going to be a little more difficult. So the easier route is just to check your answer by plugging it in. So we're going to do that. So we're going to do a check here. We're going to take our answer. We're going to plug it back into our original here. So square root of 2 times 19 over 2 minus 3. Does that equal 4? So we do that math there. So the 2's are going to cancel. We get 19 minus 3. 19 minus 3 is 16. And the square root of 16 is 4. So 4 does equal 4. So 19 over 2 is our answer. Now, you must show the check, or you need to show what the domain is. So the easier of those is going to be just checking your answer for those. You must show that in order to receive full credit on these problems on your exams. When you show your check, I do need to see the first line of you plugging it in. I understand you can do all of this on the inside in your calculators, so I do need to see these last 2 lines though. So at minimum, I need to see that much when you're doing your check. Don't make the assumption, yeah, it all is going to equal that or not. I want to see the math that creates that piece, okay? So make sure you're doing that. And I will deduct if you do not do those things, okay? So you have been warned, so please make sure that you're doing that. All right, number 2. We have the third root of x plus 5 equals 2. Right, so again here, we just want to use that index. We can see the radicals by itself. There's nothing added or subtracted. You will see an example of that later. So don't worry if you're confused on what I mean by that. I'll show a specific example in a little bit. But since there's nothing added or subtracted on the outside of that radical, we can take our power of the index as the power. So the third root and the third power cancel, leaving me with x plus 5. And then 2 to the third is 8. So we subtract 5, so x equals 3. Now in this case, when we think about a third root, the third root does not have a domain issue. The domain for a third root, our domain here is all real numbers. So we don't have an issue for those. So you can just write all real numbers for your domain, or I'm not really worried about that one because there's not a domain issue there. Now on the square roots or any even, fourth root, sixth root, eighth root, any of those, you do need to focus in on that domain because it is important. We have an issue with negatives underneath that radical, and so we have to be careful there when we're doing those, and that's why we must check those answers. All right, number 3. It's square root 2x plus 1 plus 7, sorry, 2x plus 7 equals x plus 2. All right, so this time we still have our radical by itself. So notice on the side with the radical here, we don't care about any of the rest of it. There's no adding or subtracting outside the radical. So that's still good. Which means we can go ahead and start doing our powers. So my power is 2. My power is 2. So again, on this side, the square and the square root is going to cancel out. It's leaving me with 2x plus 7. On the other side, we've got to be careful. We do need to remember that this x plus 2 squared is x plus 2 times x plus 2. So we need to FOIL that out and combine like terms so that that piece, this x squared plus 4x plus 4, goes in place here. Okay? Make sure you work that out, because if you're not working that out, you're going to end up doing it wrong. There is technically a shortcut, but you should. I've not talked about that shortcut before, so you probably need to go to the side and work that out. Okay. All right, we've gotten rid of the radical. So now we can start trying to work this out. We see a square, x squared here. So that means that I need to get everything on the same side of the x squared so that I can factor. And so we're going to move this 2x over with the 4x. My x squared is going to come down. So I'm subtracting 2x from 4x. And that's going to give me a positive 2x. And I'm going to subtract 7 from 4 and get negative 3. And over here is a 0. Okay, because we've moved those things off that side. We want it to equal 0 because that's what we need in order to factor and solve. So 0 equals, we do our parentheses and we're going to see we're going to get x plus 3 and x minus 1. Well, that means that we can do x plus 3 equals 0. I don't need this parentheses. Don't know why I put it there. Probably because I'm just seeing it. And then x minus 1 equals 0. So we solve, we get x equals negative 3 and x equals 1. Now, before I move on to the check, I do want to talk about something real quickly on our last exam. I noticed that quite a few students in my classes were leaving the 0 off right here. We shouldn't be doing that. We are solving, so I should have an equals. I should have something on the other side of the equals. And so we have to put it there for it to be mathematically sound. Also, in order to move to the next piece, that 0 has to be there again to be mathematically sound. If not, then why are we setting those pieces equal to 0? The other thing I'm seeing is if you are putting this, some students are also then just jumping to the answer. Again, I want to know how we're getting things done. So sometimes they're not as easy as this problem. Most of the time they are, sometimes they're not. So I need us to show all those steps though. The point of this is to make sure we know what's going on, not what we think happens to be going on with us. And so here we need to set each one of those equal to 0 and solve. I'm expecting to see all of those things when I grade your exams. So please start doing that if you haven't been. All right, so now we need to check those answers. Again, we're going to take those and plug them back into the original. So one at a time. So I'm going to do my check over here. So for my first one, I need to plug in -3. So again, I'm just going to separate this. So 2 times -3 plus 7 equals -3 plus 2. So in here, we're going to get -6 plus 7 is 1. And then -3 plus 2 is -1. The square root of 1 is 1. That does not equal -1. Those are not true. So we cannot use -3 there as an answer. We have to throw it out. Okay, so let's do the other one. 2 times 1 plus 7. Does that equal 1 plus 2? All right, well, 2 times 1 is 2, plus 7 is 9. 1 plus 2 is 3. The square root of 9 is 3. So 3 does equal 3. So our answer there is 1. Now, I mentioned some negatives earlier. Don't go with the assumption that just because the answer is negative, that we're going to throw that out every time. You have to check it and show that work. I expect to see you checking your work there on those. And then sometimes when we plug that negative in, the way the math works, it becomes positive through the math, and the negative does work. So don't make that assumption that just because your answer is negative, that's the one you're going to throw out. All right, next one. 3 times the square root of x minus 1 minus 1 equals x. All right, so here we can see now we have some multiplication, but we don't care about that. But we do have a subtraction here. So we don't like those. So anytime that we have that type of thing going on, we need to move that over and get it off of that radical. And so we're going to add this 1 over to the x. So now we're going to have 3 square root of x minus 1 equals x plus 1. So now I've got that radical. There's nothing added or subtracted to the radical. Now the 3 being multiplied is fine. We'll take care of that. Because if I move that off by division, I'm going to create fractions. And we don't like fractions a whole lot. Right? We'll work with them if we have to, but I don't want to create some more of an issue by making fractions if I don't have to. All right, so now we need to still square this. Okay, so over here, now we got to be careful. We have to square the 3 and we have to square the square root. So when I square the 3, we get 9. When I square the square root, we've got to be careful and put what's inside in parentheses. Those are probably the 2 most missed things on these problems. Not squaring the 3 or not putting what's inside the square root in parentheses. See, both of those things happen all the time. Sometimes it's one of the problem or both of the problem. So we want to make sure we're doing those things correctly. All right, then over here, again, we would go to the side, we would square that out, but after we do that, you should get x squared plus 2x plus 1. Okay? All right, so now we distribute, we get 9x minus 9 equals x squared plus 2x plus 1. So we see that quadratic, the x squared, so that means I need to move everything over again. I'm going to have 0 x squared. I'm going to move that 9x over with the 2x by subtracting minus the 9x. It's going to end up giving me a negative 7. I'm going to add the 9 to the 1, and we're going to get 10. Right, so now we have our 0 equals. We can factor this, we're going to see that we get x minus 2 and x minus 5. So we can set those things equal to 0. So x minus 2 equals 0, x minus 5 equals 0. So x equals 2 and x equals 5. We create a little more space here so that we can check that. All right, now let's do our check. And so for the first one, we always go back to our original. So 3 square root, and we have 2 minus 1 equals 2. Now I'm going to put that in parentheses, even though it's not necessary. I have a tendency a lot of times when I go to do my second one, I look here instead of back to the original. So I want to make sure that I plug things in the correct places. And so putting parentheses lets me know that's where I plug things in. So I do recommend that you do that. All right, so we're going to get 3, 2 minus 1 is 1. So the square root of 1 is 1. And at this point, we can do all of that. 3 times 1 is 3, minus 1 is 2. So 2 does equal 2. So that's good. We get to keep that one. Now we need to do the 5. Okay. All right, so 5 minus 1 is 4. Square root of 4 is 2. 3 times 2 is 6. 6 minus 1 is 5. 5 does equal 5, so we get to keep that one as well. So since I have 2 answers, I'll go ahead and write that in our braces as we've done before. And all of them will probably be that way as well when we have 2 answers to that. Okay. All right, so we can see moving those things around, doing all of those pieces. 1 second here. Gotta get my coffee in. Okay. If you need to finish copying this down, press pause. But I need the whole board for the next problem. It's a pretty long problem, and so I need the whole space there. All right, I believe this is number 5. Get my paper. All right, square root of x plus 2 plus square root of 3x plus 4 equals 2. All right, so this time we have 2 radicals. Now we still want to get one of those radicals by itself. So we've got to do that. So we got to start there, get one of them by itself, and then we'll move on and see what happens with the other one. Okay. Now it does not matter in this case. Both of them are positive. Which one I move. When I move them over, I'm going to have to subtract them, and that's okay. We'll work through that. Now, if I did have a subtraction, I would probably move that one over. That way I don't have a negative in front of a radical that's by itself. But at the end, it doesn't really matter. All the signs will work themselves out. Okay. So the first thing I want to do is I'm going to go ahead and move this 3x plus 4 over so that I have square root of x plus 2 equals 2 minus the square root of 3x plus 4. Okay, so now I have a single radical by itself. So that means I can square both sides. So I'm going to do that. Square here and the square here. And this side's the easy side. The square and the square root cancel out, leaving me with x plus 2. But over here, we've got to remember, because I have a minus in there, I need to write that twice. And so I'm going to go ahead and do that. I'm going to work that out within the problem this time, because I know we've probably not seen or dealt with that very much. We have these big radicals like this. Okay. All right, so now we need to FOIL this out. So my x plus 2 is going to stay. So 2 times 2 is 4. 2 times a negative square root is negative 2 square root of 3x plus 4. Negative square root times 2 is negative 2 square root of 3x plus 4. And then here, when I do my negative square root times negative square root, well, negative times negative is a positive. And because those square roots are exactly the same, that's like squaring it. So the radicals cancel out, and I'm left with what's inside, 3x plus 4. Now, technically, I don't need those parentheses because it's a plus in front of it. If it was a minus, then we may have an issue there. But you're not going to have that because of the way the problem is working. So that should be a plus. So I can ignore those parentheses. I just like to do that in parentheses to emphasize that that all goes together. Okay. All right, now on that side, we do need to combine like terms. I still have my x plus 2 over here. So 4 plus 4 is 8. I do want to go ahead and just bring this 3x over with it. But then finally, I have these two radicals that have the same things underneath it. And so we can combine those coefficients. So negative 2 and negative 2 make negative 4 square root of 3x plus 4. Okay? So I know that that still looks ugly, but we only have one radical now. Everything else we can move together, get that radical by itself. So let's do that. So to get that radical by itself, the first thing is I want to move this 3x over with this x. So I'm going to subtract it and get negative 2x. Then I'm going to subtract the 8 from the 2 and get negative 6. And then that equals negative 4 square root of 3x plus 4. So now I've gotten that square root by itself, much like in the last problem. Okay. When I've got a lot of negatives going on there, I see something special happening. Now, this step you don't have to do. There are many different options from here with this, but I do recognize something. I do recognize that these numbers outside the radical, negative 2, negative 6, and negative 4, I can divide them all by the same number. And I'm going to do that. That's going to give me smaller stuff to deal with later on. And it's going to allow for me to get rid of these negatives and kind of work with positives. We're just better with positives than we are negatives. So I can divide all 3 of those by negative 2. Okay? And I'm going to do that. Now I did negative because the negative in front of the 2, everything's negative, and I want positive. And then I did 2 of them. Now it has to be an all or nothing. The 4, the 6, and the 2, I have to be able to divide all of them, not 2 of them, not 1 of them, all of them. Okay. Now we don't go into the radical. It's only stuff on the outside of the radical that we're dividing there. Okay. All right. So negative 2 divided by negative 2 is a positive 1x. Negative 6 divided by negative 2 is a positive 3. Negative 4 divided by negative 2 is a positive 2. And then we'll have 3x plus 4. Okay. So now I've kind of cleaned up all those signs. I've made smaller numbers. So that's going to help me with that. Okay. All right. Well, now I can square both sides again. It's okay that I'm doing it twice. I've got to get rid of those radicals. This is the only way that we can do that. All right, now over here, again, you would go to the side, x plus 3 times x plus 3, and if you do that, you're going to get x squared plus 6x plus 9. And then on the other side, we're going to square the 2 and get 4, and then the inside is going to be in parentheses. Getting ahead of myself there, 3x plus 4. And so that square root went away, just like every other problem. Okay. All right, let's distribute that 4 in. So we're going to get 12x plus 16. I have an x squared, so I need to move those things over. So I'm going to get x squared. I'm going to subtract 12 from 6 and get negative 6x. I'm going to subtract 16 from 9 and get negative 7. So now I can factor. I'm going to get x minus, oh, what is that, 7 and x plus 1. And so that means that x minus 7 equals 0 and x plus 1 equals 0. So x could be 7 and x could be -1. Okay. So we found our possible answer choices. But again, we still have to go back and check these. So I'm going to do that right over here. All right, so for 7, we need to plug that in. I always like to go back to my original with these. So we have 7 plus 2, and then 3 times 7 plus 4 is all of that equal 2. All right, well, 7 plus 2, that's 9. 3 times 7 is 21, plus 4 is 25. 9 gives me, square root of 9 gives me 3. Square root of 25 is 5. 3 plus 5 is 8, not 2. So the 7 does not work for that one. Now, we can't assume that the -1 automatically works. So we have to check that. And so we have 1 plus -1 plus 2. 3 times -1 plus 4 is that equal 2. So -1 plus 2 is 1. 3 times -1 is -3 plus 4 is also 1. The square root of 1 is 1 plus 1. So 2 does equal 2. So that is good. So our answer is -1. Okay? And there's really not a shorter way to do this problem. You have to show those steps. You're going to have a homework problem like that. I believe you possibly will have an exam problem like that. So you have to be able to recognize those pieces and work through it for them. So be prepared to do all of that. Okay? Make sure you're showing your check as well.